good morning everyone. I'm Suhasini. Welcome back to my channel Learn with Suhasini Shinde. Last class we have studied about the properties of electric charges, right? Fundamental properties of electric charges like additive property, conservation of the charge and the quantization and charge. And then we also look into the general properties of the electric charges, right? And today's class we'll be learning about the Coulomb's law. Now this particular Coulomb's law can be defined in three different ways, right? It can be asked in three different ways. It can be Coulomb's law, or it can be Coulomb inverse law, or Coulomb law in scalar form, right? All the three means one and the same. You please do not confuse whenever it is asked. See, the students are usually tend to be practicing the same notations and the same abbreviations, right? Once it is asked out of the things, then you get confused, right? They can ask you anything. Coulomb's law in scalar form also means the same. Coulomb's inverse law is also the same, and Coulomb's law is also the same. But most of the time the question will be directly asked on Coulomb's law, right? Now before moving into this Coulomb's law, the very first point that you have to note down here is you use always a point charge, right? In the entire explanation further, this particular point charge is being used. What these point charges are? Point charges are very minute charges, right? Very small, like you cannot even see in whole of this board. If at all you consider this board, this is a board, empty space, a very small dot, right? When you see, there is nothing, but when you see very carefully, you have some dot over there, right? You feel some existence of the charge. It are so small, right? The point charges are so small that the distance between 2 point charges is very big when compared to their original sizes, right? This is called as a point charge. Now this point charge is oftenly used in the further explanation, so you have to know what point charge is at this particular point, right? Now before moving on to the Coulomb's law, first you understand the general concept of the charge. Say, whenever I say a charge, right? Now this is a charge. Whenever I say a charge, it always has electric field around it, right? Any charge placed at any particular time always has electric field around it, right? Now this is our field lines, electric field lines. Now if anybody, say anybody or any other charge is coming into this particular region, will experience force on them. Why? Because of this electric field lines, right? Any body that is coming into that particular region of electric field will experience force on themselves, right? And if at all, say for example, you have another charge here, right? This also has its electric field, right? Then what does it mean? Now this is, says for example, it is charge 1, this is charge 2. Now charge 2 is experiences force on it due to the electric field lines of Q1, and in the similar way charge Q2 also experience some force on it due to the electric field that is generated by charge Q1, right? So now in this Coulomb's law, what we do is we find out what is the exact amount of the charges, that is what is the exact amount of the force that is being produced in between these two charges, right? When I said you, there is, whenever we have a charge, it produces some electric field lines around it. When you have another charge, it also produces some electric field around it. So any point or any body entering into that particular field line region will experience on force, right? Experience some force. Now this force is because of both of with each other, right? Q2 will be experiencing some force because of charge Q1, right? And in turn Q1 will be experiencing some force on it because of the charge Q2. What is this force? How do we find out this force? This force is found out by using Coulomb's law. You understand why Coulomb's law is studied? The Coulomb's law is studied to find out what is the force between 2 point charges. What is the force between 2 point charges, whether it is attractive force, whether it is repulsive force, what is the force that exists between 2 point charges is being explained into this particular Coulomb's law. Is this clear? Now let us learn Coulomb's law, right? What does the statement for the Coulomb's law says? The electrostatic force between any 2 point charges is directly proportional to the magnitude of the charge and inversely proportional to the square of the distance between them. And the force always acts along the line joining the two charges, right? For example, say let us say you have 2 point charges. I have told you what point charges are. Now there are 2 point charges Q1 and Q2, right? Both are experiencing force on each other because of the electric field lines of their respective charges, right? Now Q1 and Q2 are the charges. They are kept at some distance, say D. D is the distance between Q1 and Q2, right? Is this understandable up to this point? There are two charges separated by the distance D. Now what does the statement says? The electrostatic force between any 2 point charges is directly proportional to the magnitude of the charge. What does this mean? Now this entire theoretical statement will be converted into mathematical expression, right? These are not just lines that are said. Now each and every particular line and word has some meaning into it, right? Now this particular statement will be converted into the mathematical expression. Now come up to this point, the electrostatic force between any 2 point charges is directly proportional to the magnitude of the charges. The very first statement, that is electrostatic force between any two charges is directly proportional to the magnitude of the charges, right? And next, and inversely proportional to the square of the distance between them, and inversely proportional to the square of the distance between them, right? Is this understandable now? The whole statement of the Coulomb's law is converted into the mathematical expression. Whenever you write a mathematical expression, you make sure that there are no proportionality constants into your statement or into your expression. Right, now this is the proportionality constant. So we replace this proportionality constant with another term called as proportionality constant. Right, we write it as F will be equal to K Q1 Q2 divided by D square. Right, the electrostatic force between any two charges is directly proportional to the magnitude of the charges and inversely proportional to the square of the distance between them, right? And now this particular equation is called as Coulomb's law, that is Coulomb's law or the electrostatic force equation, right? Now this proportionality constant is different for the different types of the medium, right? Not necessary always the point charges are kept at some particular medium. You understand what medium is? Medium can be any region, right? If at all in this particular region you have air, then it is air medium. If it is filled with water, it is water medium. It is filled with oil, then it is oil medium, right? Now the medium in which the charges are kept, right? That will define what K value is. Right, now this proportionality constant value will be changing with the change in the medium where these charges are kept, right? It is not necessary the charges are always kept into water or always kept into air or always kept into vacuum, right? There are different types of the scenarios where the charges are placed, and hence because every time when you place the charges, the force might not be same for all the things, right? The same two charges when kept in water could have different force of attraction or repulsion in between them. When the same charges when kept in the vacuum might have again different charges of the different energy of repulsion and the attraction, right? And hence this proportionality constant will tell you what is the exact value of the force in between the two charges when kept in certain medium. And now the value of the K in SI unit will be equal to 1 divided by 4 pi epsilon, where epsilon will be equal to epsilon naught and epsilon r, right? Now this epsilon naught has the value 8.854 into 10 raised to minus 12 Coulomb square per Newton per meter square, right? And this relative permittivity will depend on what medium that you are placing the charges, right? For example, if at all these two charges are placed in free space, or say for example free space means air or vacuum, then the relative permittivity for that particular medium will be 1. Right? The relative permittivity of the air and vacuum ER will be equal to 1. Then how do you represent the force equation now? Force will be equal to 1 divided by 4 pi epsilon. Actually epsilon r, but this is 1, right? Why? Because we have kept the charges in the air or a vacuum for which ER value will be equal to 1. So we only write epsilon naught, right? So the force will be equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by D square, right? Now this is the force equation when two charges are kept into air. Now If at all you want to again simplify this equation, then this can be further simplified by putting all the values, right? 1 by 4 pi epsilon can have the value 9 into 10 raised to 9. How is this 9 into 10 raised to 9 got? 1 divided by 4 pi epsilon, you write it like this in terms of values. 1 divided by 4 is 4, right? Pi is the value 3.14, epsilon naught is the value 8.854 into 10 raised to minus 12, right? When you calculate this thing, you get the value of 1 by 4 pi epsilon naught as 9 into 10 raised to 9, right? Instead of writing the whole equation, this thing, you can directly put the value 9 into 10 raised to 9 in the equation, right? Now say for example, you have two charges. You know that you have two charges. Whenever I say charge, there is always a magnitude to it. Say for 2 coulomb, 3 coulomb, 4 coulomb, right? Whenever I say charge, there is magnitude, right? So when I say there are two charges, then there should be definitely some magnitude of Q1 and some magnitude for Q2. Say for example, the Q1 and Q2 are unit positive charges. What does unit positive charge means? A charge whose magnitude is 1 is called as unit positive charge. Say for example, Q1 and Q2 are equal to 1 coulomb, right? And the distance between them is 1 meter, right? The two charges are magnitude 1 coulomb and the distance between the two charges is 1 meter. Then what do you write? What is the force? See, force will be equal to, right? What was the value for one? I'll just tell you once again. What was the value for the force? Force is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by d square, right? This value we have got, that is 9 into 10 raised to 9. So substitute that. F is equal to 9 into 10 raised to 9, right? Now what we have considered, the two charges are of 1 coulomb and the distance between them is 1 meter, right? Now you put that 1 into 1 divided by 1 square. Now this is nothing but F is equal to 9 into 10 raised to 9 Newton, right? Now this particular force will be the force between the two charges when they are kept into the air or vacuum, right? Now this force can be either repulsive or either it can be attractive depending upon the charges that are present. For example, if Q1 and Q2 are positively charged with the distance of 1 meter in between them and with their own magnitude of 1 coulomb and 1 coulomb, what will be the force between these two charges? It will be repulsive because there are two like charges. What is the force? What is the amount of the force between them? It is 9 into 10 raised to 9 Newton. Say for example, again you have two charges, Q1 and Q2, right? One is positive and one is negative. The distance between them is 1 meter and these magnitudes are 1 coulomb, right? What is the force between them when the two charges kept in air or the vacuum with a distance of 1 meter, right? It is again 9 into 10 raised to 9 Newton, but this time the force will be attractive. Why? Because they are unlike charges. You are getting the point, right? Now this is what the Coulomb's law says, right? The Coulomb's law explains the electrostatic force between the two charges when kept in certain medium, right? If at all you have many different charges, now this force is only between 2 point charges. If at all you have many charges like this, right, then you have to follow superposition theorem that has been explained next, right? Is this clear up to this particular point, right? And one more thing. Why do I say the electrostatic force, right? Why it is not the force between any two? It is electrostatic, right? Electro means what? It is a charge. Static is what? It is not moving, right? We are finding the force between two charges which are not moving. They are in the static position, right? And hence you call any force that is existing between these two charges is called as electrostatic force. Do you understand this? And every law cannot be applied in all the aspects, right? Every law has its own limitation, and so forth. We have limitations also for the Coulomb's law, right? What is the first limitation? It is true only for the point charges. Now this Coulomb's law can be applied only when you consider 2 point charges. If the charges are bigger, then this Coulomb's law doesn't work over there, right? This is the first limitation, and it is not universal and depends on the medium. Now the force value that you are getting in between the same point charges will depend on the medium, right? If at all the charges are kept in the air, then you get a different force, and if at all you are keeping into water, it is different force, into oil is different, into vacuum is different, right? With the same charges and with the same separation and the distance between them, the force value keeps on changing with respect to the medium, and hence this is a limitation for this Coulomb's law, right? The third limitation is it is verified over distance from small distance to kilometers, right? Whenever the charges are kept with a very small distance and up to the point of kilometers together, the value of the force keeps on changing and it is not confined, right? This is one particular limitation. And the last limitation for the Coulomb's law is whenever the two charges are kept at a distance less than 10 raised to minus 15 meter, then it doesn't show, or we do not get any proper value of the force between the charges, right? And hence these four things are the limitation for the Coulomb's law. And this particular question can be asked either 3 marks or 5 marks, right? If at all they ask only limitation, then it can be asked for 2 marks, right? If they are asking state and explain Coulomb law along with the limitation, then it can be asked for 5 marks, right? The entire explanation what I have given previously, that is for the Coulomb's law, the whole entire derivation and along with the limitation, this particular question carries 5 marks, right? If they ask only the limitation, then it will be asked for 2 marks, right? Is this clear now? By this time you know what Coulomb's law is. Whenever you want to know what is the electrostatic force between 2 point charges, then Coulomb's law is used. What if there are so many charges, right? Then when you want to know what is the force on one particular charge due to many charges that are present around it, then you follow superposition principle. Say for example, you had a charge Q1 right here, and you have so many other charges here. Say Q2, Q3, Q4 and Q5, right? You want to find out what is the force on this particular charge, say Q1 due to Q5, due to Q4, due to Q3 and due to Q2, right? There is some force exist between all the charges here, right? There is some force exist between Q1 and Q2, Q1 and Q3, Q1 and Q4 and Q1 and Q5, right? We want to find out a force, that is electrostatic force on the charge Q1 due to various other charges that are present. When you have so many charges and when you want to find out the electrostatic force, then you go through superposition principle. If there are only 2 charges, say Q1 and Q2, and you want to find out what is the force between them, then you go for Coulomb's law, right? Is this clear why these two separate things are being explained? When only 2 charges, go for Coulomb's law. When there are so many charges, then go for superposition principle, right? What does the superposition principle says? The statement for the superposition is force on any charge due to number of the other charges is the vector sum of all the forces taken one at a time. Individual forces are unaffected due to the presence of other charges. What does this statement means? This statement means the force on any particular charge will be equal to vector sum of all the charges that are present, right? The force that was exerted by Q5 on Q1 will be added to the force of this Q4, will be added to the force of Q3 and will be added to the force of Q2, right? The vector sum of all the individual forces will be coming together, will generate a net force on this particular charge Q1. Say for example, now net force, right, on particular charge Q1 will be representing force because of 2 plus force because of 3 plus force because of 4 and plus force because of 5th charge, right? The total force that is experienced on charge Q1 will be equal to the vector sum of all the forces that are present around it, right? Now what does this particular statement indicates? Individual forces are unaffected due to the presence of other charges. What does it mean? It means any force in between any two charges are independent. Q5 and Q1, the force between Q1 and Q5 is not affected by the presence of Q4, right? And the force between Q4 and Q1 is not affected by the presence of Q3, right? Any force that is present or any force that is imparting on Q1 is not affected by any all other the charges that are present, right? And hence the superposition principle says force on any charge due to number of other charges is the vector sum of all the charges, and individual forces, that is F1, F2, F3 and F4, individual forces are not affecting each other over this particular time, right? Is that clear, right? And now you just understand, you just make a note whenever you want to calculate the electrostatic force between 2 point charges, you use Coulomb's law, and whenever you want to calculate what is the force on particular point due to many charges, then you use superposition principle. Is that clear? Okay, now we will derive the expression for the force due to many charges, right? Now consider we have charges, say Q1, Q2, Q3 and up dash up to Q1. Say this is Q1, this is a position of Q1. You have Q2 charge, you have Q3 and you have dash up to Qn charges. Now you want to find out what is the force on the charge Q1 due to Q2, right? What is the force on the charge Q1 due to Q3? What is the charge force on Q1 due to Qn charges, right? Now what is the net force? How we can write what is the net force on the charge 1? It is force on charge 1 due to 2, right? This notations are represented like this. Force on charge 1 due to 2, right? Plus force on charge 1 due to 3, right? Plus dash up to force on charge 1 due to nth number of the charge, right? This is the net force that is present on this particular charge, say Q1, right? Now individually when we take F12, F13 and F1n, how do we write? What is the force that is present in between the two charges? Say for example F12. Now this we have seen in Coulomb's law. What was the force that was present in between the 2 point charges? These are all point charges, right? In Coulomb's law we had only 2. Here we have many. But when we derive the superposition principle, we again come back to the Coulomb's law and find out what is the force between the two charges. Now these are the two charges independent, acting independently. Now what is the force between Q1 and Q2? It is 1 divided by 4 pi epsilon naught Q1, right? Q2 divided by the distance between them. Say for example the distance between this is R12. Why is this 12? The distance is from 1 to 2, that is R12, right? You can write R12, right? Now this is the force in scalar form, right? To represent this particular force in vector form, what has to be written? R12, a vector. This is a directional vector, has to be included, right? Now what is the force? Now this is done. What is the force between 1 and 3? What is the force between the charge 1 and charge 3? How we can write? Force 1, 3 will be equal to 1 divided by 4 pi epsilon charge Q1, and it is between charge Q3 divided by what is the distance between them? Say for example the distance between them is R13. So it is R13 square. Sorry, it is square here, right? And what is the directional vector? The force is acting in between what direction? In between the point 1 and 3. So it is directional vector 1 to 3, right? On the similar lines, what is the force that is acted by the nth electric charge? That is F1n will be equal to 1 divided by 4 pi epsilon Q1 Qn divided by R1n square, and this particular force is acting the line joining these two, that is 1n, right? Now these are all the independent forces that are acting on this particular charge Q. Now the vector sum of all these forces will be equal to the net force that is acting on this particular charge, say Q1, right? Now, the net force can be written as, you add all this 1, 2, 3, that is 1 divided by 4 pi epsilon naught Q1 Q2 divided by R12 whole square, right? The directional vector is written later, plus 1 divided by 4 pi epsilon naught Q1 Q3 divided by R13 whole square, right? Plus dash dash up to 1 divided by 4 pi epsilon naught Q1 Qn divided by R1n whole square, right? Now this is the total net force that is acting on charge Q1 alone due to all the charges Q2, Q3, Q4, Q5 dash dash up to Qn, right? Now how can this explained? Now this particular expression can be simplified and written, say for example, F net, that is the total force, that is net force on the charge Q1 will be equal to, what is common here everywhere? Q1 and 1 divided by 4 pi epsilon naught is common. So you take that 1 divided by, Q1 and 4 pi epsilon naught is common, right? Put a summation, right? Now from what charge it starts? Q1 is already there. Q1 is fixed now. You want to find out what are the charges, the other charges, right? So it is I is equal to from 2 to n. When is this summation written? Whenever you have a range of some particular things, when you know the starting point and the end point, then you write this summation, right? Q1 is very common, it is fixed now, right? There can be so many different types of the charges around it. It can be second charge, third charge, fourth charge, up to n amount of the charges. So it is written summation, right? Now again here will be equal to Qi, right? R1I. It is a general formation, right? General format of writing. Next, a directional vector R1I. This is the net force that you get on the charge Q1 due to all other charges Q2, Q3, Q4, Q5 and so on up to Qn. This is the force that we get, and this is the expression, final expression for the superposition principle. Is that clear? And this was all about today's class. Hope you people have understood it. Right, in the very next class, we'll be learning electric field intensity, and the material and the content for this particular chapter is given into description box. You please go visit my website, download the notes and you can study. It becomes very easy after listening to the videos, going back and getting into the same materials makes you very conveniently remember the things, right? And please do subscribe my channel, share my videos with all your friends and families, and like my videos, right? And thank you so much.